Assalamu alaikum dear students. This is our fifth video in Unit 6 Plane Analytic Geometry and first video in exercise 6.2. The first topic of this video is slope of a line. Dear students, slope of a line is the measure of the steepness of the line and it is calculated from the rise per unit run of the line. Dear students, steepness is the main idea of this topic. So we first come to understand what the steepness of a line means. For this we consider the following situation. Suppose here is a competition between the students of second year class. We have two students A and B and two ladders L1 and L2. The student have to climb these ladders L1 and L2. Dear students, what is your opinion? Which one is easier to climb? Either L1 or L2? I think the wiser one will select ladder L1 because ladder L2 is more inclined to the vertical and it is difficult to climb L2. The one who is climbing L2 would feel more fatigue as compared to the fatigue felt by the one who is climbing L1. The basic reason is that L2 is more inclined to the vertical as compared to L1. So the steepness of L2 is more than the steepness of L1. And the measure of the steepness is called slope. So we can say that the slope of the ladder L2 is more than the slope of the ladder L1. And this is why it is difficult to climb L2 as compared to L1. Now dear students, suppose that a point is moving from the end cap of the ladder L1 O to a point B. The image of this point moves from O to A by covering a horizontal distance delta x and a vertical distance delta y1. If a point moves from the end cap O on the rail of ladder L2 from O to C, its image moves from O to A by covering the same horizontal distance delta x. We observe from the figure that in case of the ladder L1 the vertical distance is delta y1 and in case of the ladder L2 the vertical distance is delta y2. Dear students, delta y2 is greater than delta y1 as ladder L2 is more inclined to the vertical than ladder L1. So we observe that if a ladder is more inclined to the vertical distance covered by the point is more than the vertical distance of the ladder which one is lesser inclined to the vertical. Thus we observe that by keeping the same value of delta x, the inclination to the vertical, which is the steepness, increases as delta y increases. The steepness depends upon the vertical motion when the horizontal motion is kept constant. Thus, dear students, we have observed that if the inclination of a ladder to the vertical is more is the steepness of this line and more is the slope of that ladder. Now we come to this point from another perspective, that is the angle inclined by the ladder with the horizontal. Dear students, we observe that here is the angle theta 1 subtended by ladder L1 with the horizontal and here is theta 2. The angle subtended by the ladder L2 with the horizontal. We see from the figure that theta 2 is more than theta 1 and theta 2 is the angle of the ladder which is more inclined to the vertical. Theta 1 is the angle of the ladder which is less inclined to the vertical. So we observe that the angle with the horizontal is more if the ladder is more inclined to the vertical, and the theta with the horizontal is less if the ladder is less inclined to the vertical. So from this perspective, we can say that more is the slope of a line if its angle with the horizontal is more. Thus, from the angle with the horizontal, we can observe the slope of a line. Suppose here is a point at A, having coordinates x1, y1. When this point moves along the straight line to the point B having coordinates x2, y2. We have already observed that when the point moves in the plane on this straight line from A to B, it covers a distance of AC in the horizontal direction and a distance of CB in the vertical direction. We observe that AC distance is x1, x2 distance, which is delta x, and CB distance is y1, y2 distance, which is delta y. Dear students, you know that this angle and an angle at the vertex A are corresponding angle. So we can say that BC is the perpendicular, AC is the base, and AB is the hypotenuse of this right angled triangle. Now dear students, we have observed that slope is actually rise divided by run. Now we observe rise in this case. Dear students, we know that when point moves from A to B, it covers a vertical distance of BC. And you know that vertical distance or vertical change, which is delta y, is actually the rise. And similarly, when point moves from A to B, it covers a horizontal distance of AC. And this horizontal distance or horizontal change is called run of the point. So the rise is actually equal to delta y and run is actually equal to delta x in this case. So rise can be replaced by delta y and run can be replaced by delta x. Dear students, we have observed that delta y is the change in y, which is equal to y2 minus y1, and delta x is the change in x, which is equal to x2 minus x1. So this is the first relation for the slope of a line. Dear students, we observe that here is a right angle triangle ABC. The perpendicular of this triangle is BC, but we know that BC is actually delta y. And this is perpendicular. And the base of this triangle is AC, and we have observed that AC is equal to delta x. And delta x is the base of this triangle. So delta y is the perpendicular and delta x is the base of the triangle. You know that in a right angle triangle, perpendicular divided by base is tan of theta. So this is the second relation, which is in terms of the angle subtended by the straight line with the horizontal. Dear students, the slope of a line is sometimes called the gradient of the line. Here's the symbol M is used for the slope. Now we come to know what is the dilemma of this slope. Sample. Dear student, we have found many students that are crazy about the symbol M used for slope. In the concise encyclopedia of mathematics, it is written that the letter M was first used in print as a symbol for slope in the mid-19th century. According to this saying, this symbol was used by a British mathematician, Matthew O'Brien. But a scholar of the University of Torino in Italy He has written this. This symbol was firstly used by an Italian mathematician, Vincenzo Riccati, in 1757. Dear student, it is a point to be noted that in the work of earlier mathematicians, it is found that slope was denoted by different symbols. In Swedish, slope is denoted by K, which is probably stands for the coefficient with K. Some people say that the symbol M is for the French word monter, which means to climb. But the French mathematician René Descartes never used the symbol M for slope. Dear students, some other people say that this symbol is for the first word in modulus of slope. Dear students, what the fact is, we don't care. But the reality is that this symbol has done a lot of business as a symbol of slope. Now we come to know something more about this idea. For this we are considering the following example. Find the slope of a line that passes through the points A with coordinates 2, 3 and B with coordinates 3, 5. Dear students, this is the first point and this is the second point. Suppose that this point is A, x1, y1, the first point. Comparing the coordinates, we have x1 is 2, y1 is 3. And this is the second point, and we have taken it x2, y2. Comparing the like coordinates, we have x2 equals 3 and y2 is equal to 5. As you know that one of the definitions of the slope is m equals y2 minus y1 divided by x2 minus x1. As we are here, we have points, so we are using that definition. Now putting the values, y2 is 5, y1 is 3, x2 is 3 and x1 is 2. After calculations we get 2. Thus the slope of this line is 2. What this slope means? Dear students, here we observe that there is a 2 unit of run for a single unit of there is a 2 unit of rise for a single unit of run. So when the slope is 2, it shows that for each horizontal unit of change, there is 2 unit of vertical change. And this is the end of this video.